NISAR launch, NASA-ISRO satellite to map Earth in unprecedented detail. Imagine a satellite so powerful it can detect the slightest shifts in Earth's surface, warning us of impending natural disasters before they strike. This isn't science fiction, it's the reality of the NISAR Earth Observation Satellite, a groundbreaking collaboration between NASA and the Indian Space Research Organization, ISRO, set to launch on July 30th. This mission marks the first time these two space agencies have joined forces on an equal footing, and the potential benefits are immense. NISAR, which stands for NASA-ISRO Synthetic Aperture Radar, will provide us with the most detailed and sensitive map of Earth's surface ever created. Its advanced radar technology can detect movements as small as a fraction of a centimeter, whether it's the ground, ice, or even the subtle shifts of tectonic plates. This level of sensitivity is crucial for monitoring natural disasters, from earthquakes and volcanic eruptions to land subsidence, ice sheet movements, and wildfires. For instance, NISAR can track slow-moving landslides, where a mountainside might creep by mere centimeters each day before suddenly collapsing. By identifying these slow changes, NISAR can provide early warnings, potentially saving lives and infrastructure. But here's where it gets controversial. While the technology is undeniably impressive, some critics argue that the cost of such advanced satellites could be better spent on ground-based monitoring systems. They question whether the benefits of space-based monitoring justify the high financial investment. What do you think? Is the investment in satellites like NISAR worth it, or should we focus more on terrestrial solutions? NISAR's dual-frequency band radar is the key to its unparalleled capabilities. The L-band radar, developed by NASA's Jet Propulsion Laboratory, JPL, operates between 1 and 2 GHz, and can see through vegetation to monitor the bare surface. ISRO's S-band radar, operating between 2 to 4 GHz, is sensitive to vegetation and foliage. Together, these radars provide comprehensive coverage, mapping the entire globe every 12 days without being hindered by clouds. This dual-frequency approach allows NISAR to detect a wide range of surface changes, from the movement of glaciers to the spread of wildfires. These two radars work together to accomplish science that neither can see on their own, said Wendy Edelstein, NISAR's deputy project manager at JPL. The radars feed into a massive 12-meter, about 40 feet, antenna, which unfolds to the size of a tennis court. This antenna is made of a lightweight mesh, allowing it to fold compactly for launch. The synthetic aperture radar technique used by NISAR takes advantage of the satellite's motion to capture high-resolution images. As NISAR flies, it beams down radar pulses, covering an area about 10 kilometers, 6 miles, long with each pulse. By capturing thousands of pulses per second, NISAR can build a detailed movie of Earth's surface, frame by frame. And this is the part most people miss. NISAR's ability to fly in an exact repeat orbit means it can use radar interferometry to measure ground movement over time. By comparing images taken at different times, scientists can detect even the smallest changes in the landscape. This technique is essential for understanding long-term trends and predicting future disasters. NISAR will launch on July 30th aboard an Indian Geosynchronous Satellite Launch Vehicle, GSLV, rocket from ISRO's Satish Dhawan Space Center in Sriharikota, India. This mission is a true partnership, with NASA contributing $1.2 billion, primarily for the L-band radar, antenna, and boom, while ISRO provided the S-band transmitter, spacecraft bus, solar arrays, and launch vehicle. The collaboration highlights the global effort to monitor and protect our planet. 10 days after launch, NISAR will begin unfurling its giant antenna, and by day 65, the first full-frame science images will be produced. I've spent my entire career working on radar missions for JPL, and NISAR is the highlight for me, said Edelstein. I can't wait to see the science that it produces and the impact that it has. I think it will help people around the world. So, what do you think? Will NISAR revolutionize our understanding of Earth's surface and natural disasters, or are there better ways to allocate our resources? Share your thoughts in the comments below. ISRO-NASA NISAR satellite launch, everything you need to know. Breaking ground, historic ISRO-NASA satellite NISAR set for launch on July 30, 2025, a milestone in international space collaboration. In a groundbreaking development that space enthusiasts worldwide have been eagerly anticipating, the Indian Space Research Organization's GSLV F-16 rocket is scheduled to carry the first-ever joint ISRO-NASA satellite mission into orbit on July 30, 2025. The launch is set for precisely 5:40 p.m. Indian Standard Time from the prestigious Satish Dhawan Space Center in Sriharikota, India. The powerful GSLV F-16 will position the NISAR satellite into a sun-synchronized orbit at an altitude of 743 kilometers, with an orbital inclination of 98.40 degrees. But here's what makes this mission truly revolutionary. NISAR, NASA-ISRO synthetic aperture radar, represents an unprecedented achievement in Earth observation technology. This 2,392-kilogram marvel is the first satellite ever to employ dual-frequency synthetic aperture radar technology, combining NASA's L-band and ISRO's S-band capabilities. Both radar systems will utilize NASA's innovative 12-meter unfurlable mesh reflector antenna, seamlessly integrated with ISRO's modified I3K satellite bus. In another technological first, NISAR will implement sweep SAR technology to scan Earth with remarkable precision, covering a substantial 242-kilometer swath at impressively high spatial resolution. And this is the part most people miss: NISAR's capabilities extend far beyond conventional satellite imaging. The satellite will conduct comprehensive global scans, delivering all-weather, day and night data at 12-day intervals, enabling an extraordinary range of applications. Its sensitivity is so refined that it can detect minute changes in Earth's surface, including subtle ground deformations, ice sheet movements, and vegetation dynamics. The practical applications are vast and varied, from classifying sea ice and detecting ships to monitoring shorelines, characterizing storms, measuring soil moisture changes, mapping surface water resources, and coordinating disaster responses. What's particularly noteworthy about NISAR is that it embodies more than a decade of intense technical collaboration between ISRO and NASA/JPL teams. This partnership represents one of the most significant international space collaborations in recent history, combining the expertise and resources of two space powerhouses. Here's where it gets controversial. As space becomes increasingly contested territory among global powers, does this collaboration signal a new era of international cooperation in space exploration? Or is it a strategic alliance in response to other nations' growing space ambitions? Will the data collected by NISAR be equally accessible to all nations, or will it provide strategic advantages to India and the United States? What do you think about this landmark mission? Does international collaboration like NISAR represent the future of space exploration, or will national interests eventually prevail? Share your thoughts in the comments about how this mission might impact global space politics and environmental monitoring capabilities. NASA-ISRO NISAR mission launching July 30th, Next-Gen Earth Observation Satellite. A groundbreaking space collaboration is about to rewrite the rules of Earth observation, and it's launching sooner than you think. On July 30th, NASA and the Indian Space Research Organisation, ISRO, will jointly launch the NISAR satellite, a mission poised to become one of the most advanced Earth monitoring tools ever deployed. But here's where it gets controversial. Could this unprecedented data-sharing partnership between global superpowers redefine how we address climate change, natural disasters, and even international diplomacy? The NISAR mission, short for NASA-ISRO Synthetic Aperture Radar, will blast off from India's Satish Dhawan Space Center aboard an ISRO geosynchronous launch vehicle. What makes this satellite revolutionary? It's the first to combine L-band and S-band radar systems, essentially giving scientists X-ray vision to study Earth's surface through cloud cover and darkness. Imagine tracking minute shifts in earthquake-prone regions or measuring glacial melt in real time. This is the level of detail NISAR promises. Here's the kicker most headlines miss: NISAR isn't just collecting pretty pictures. Every 12 days, it will map 90% of Earth's land and ice surfaces, creating what experts call a living MRI scan of our planet. The data, freely available to scientists, governments, and even citizen researchers, could transform everything from predicting volcanic eruptions to optimizing crop yields. But wait, should such sensitive environmental intelligence really be open access? Critics argue this could lead to geopolitical tensions over resource management. The mission's timing is no accident. Following high-profile endorsements from both U.S. President Trump and Indian Prime Minister Modi earlier this year, NISAR symbolizes a new era in space diplomacy. Yet one burning question remains: can this technological marvel deliver on its ambitious promises while navigating the complex realities of international collaboration? We want to hear from you. Do global partnerships like NASA-ISRO represent the future of scientific progress, or do they risk blurring the lines between cooperation and competition? Drop your thoughts below, the most insightful comments might just shape how history remembers this mission. For media inquiries, contact Andrew Wang, Jet Propulsion Laboratory, Pasadena, California. 626-379-6874. Andrew.Wang@jpl.nasa.gov.